Okay, let's start. So the sum has three parts. For the first part, we have to find out a0 plus a1 plus a2 till a2n. So we can immediately see that it is basically this equation, except that all the x terms are equal to 1. So basically x is equal to 1, and substituting x equal to 1 in this equation, we have 1 plus 1 plus 1, so that is 3 raised to n. So 3 raised to n is the answer of the first question. That's right, 3 raised to n. Okay. Now for the second question, it is a0 minus a1 plus a2 minus a3. Okay. So again, similarly, it's just this equation, except that all of the x terms are replaced by minus 1. So all the odd terms will become minus 1 and all the even terms will remain positive. So replacing x by minus 1, we have 1 minus 1 plus 1, so that is only 1, and 1 raised to n, so that's again just 1. So the answer of second question is 1. Now the third question, this one's a little bit tricky. So let's start doing it. So first, instead of x, let us write the expansion of 1 minus 1 upon x, and the reason for doing that you will understand soon. So 1 minus 1 upon x plus 1 upon x square, the whole thing raised to n. Using the given formula, we are going to write that it is a0 minus a1 upon x plus a2 upon x square all the way till a2n upon x raised to 2n. So let's take LCM over here in this bracket. So that will become x square minus x plus 1, this whole thing raised to n, and in the denominator we have x raised to 2 into n, so x raised to 2n. So let us multiply that to the other side, so that will give us a0 x raised to 2n minus, it will become a1 x raised to 2n minus 1 plus a2 x raised to 2n minus 2, and so on. Alright. So now if you look at this bracket, it is x square minus x plus 1, and this bracket is x square plus x plus 1. So if we multiply these two brackets, we know the formula for that, right? It's an identity. So that is just x raised to 4 plus x square plus 1, and this raised to n. So let us start multiplying the expansions as well. So it will be first term of this into the whole thing, then the second term of this into the whole thing again. So let's start doing that. So it will be a0 into a0 x raised to 2n minus a1 x raised to 2n minus 1, so on. And then next term is a1x, again a0 x raised to 2n minus a1 x raised to 2n minus 1. It goes on, and the next term is a2x square. So the first two terms will be the same. The third term is plus a2x raised to 2n minus 2 is this term, and so on and so forth, and this will also go on. So now over here, if we multiply this into this, we have a0 square x raised to 2n. Multiplying this into this, that will become minus a1 square x raised to 2n. Then this into this will become plus a2 square x raised to 2n, and it will go on. So we are obviously observing a pattern over here. This thing, the coefficients are exactly what we need. a0 square minus a1 square plus a2 square. That is what we asked, right? And we will observe, we can clearly see that all of these are coefficients of x raised to 2n. So in this expansion, we have to basically find out the coefficient of x raised to 2n, and that will be our answer. So to do that, it's very easy because you can compare these two equations and you will see that it's the same thing, except that instead of x we have just written x square. So the expansion on replacing x with x square will be a0 plus a1 x square plus a2 x raised to 4 goes on till a2n x raised to 4n. So obviously there will have to have been some x raised to 2n terms in between 0 to x raised to 4n. So we have to find out the coefficient of that, and we can clearly see a pattern. The coefficient is the power divided by 2. So the coefficient of x raised to 2n has to be an. That is the coefficient of x raised to 2n. So an is our answer.